Previous video we have seen how to what is graph and the types of the graph. In this video we are going to learn about representation of graph. That means that how to represent a graph, that what data structure we need to represent a graph. So our title is representation of the graph. So there are mainly two types to represent a graph. First, using adjacency matrix. Sorry for the spelling, but I think it should be adjacency adjacency matrix. Then after that we have second type of representation which is same as this, but we will use that adjacency list there. So first of all we are going to discuss about adjacency matrix. Okay, so let discuss about adjacency matrix. And now I am giving you example of graph. Like suppose that we have a graph 1 2 3 4 5 and 6. We have this graph and all of the edges as follows. So this is our graph that we have given. Now how to represent this graph? So we have there how many number of nodes are there? So there are 6 nodes. Okay, so what we'll do that we will actually draw a 6 into 6 matrix, sorry, n plus 1, 7 into 7 matrix. Okay, 7 into 7 matrix will draw. So let me draw. Okay, let me draw a table. Now what will I do? 1 2 3, let me count it. 1 2 3 4 5 6. Then one more, like 0 1 2 3 4 5 6. Only 6 is there. That is good. So I will number it around 0 1 2 3 4 5 6, and then again I will draw another grid which is horizontal grid. 0 1 2 3. And what I should do, that I should increase this, I think. Yeah, right. Now what I have, 1 2 3 4 5, and then again I will draw another like 6. So I will number 0 1 2 3 4 5, and one again I need it 6. So this is the 7 cross 7 matrix we have. Now what will I see, that first is from 1 to 3. See, 1 2 3. So I will go to 1 and the 3, there is edge between 1 and 3, so I will represent with, okay, I will represent with 1 here, because there is in as between 1 and 3. Also there is as between 3 and 1 also, because it is undirected, so there is as between 3 and 1 also. So I will go to the 3 and go to 1 3 1, and the 3 1 I will do 1. After that what I will see, that 1 and 2 also have there, so I will go to 1, and here is 2, here is 1, there I will mark as 1. 1 means there is a node between I. If a matrix ij equals to 1, it means there is edge between 1 and 2. Then again, if 1 and 2 have an edge, then 2 and 1 is also connected, so I will mark 1 over there. Then after that 2 2 and 5, so go to 2 and 5, mark as 1 there. Then 5 and 2 we have to also mark, like 5 and 2 we have marked. Then 5 and 6, go to 5, mark 6, go to 6, mark 5. Then after that 6 and 4 is connected with that, go to 6, mark 4, and go to 4, mark 6. Then again 3 to 4, go to 3, go to 3, mark 4, then go to 4, mark 3. Sorry, not there, there. Then after that 3 and 5 is connected. Go to 3, mark 5. Then go to 5, mark 3. Go to 5, mark 3. Then 2 and 4 is also connected. Go to 2, mark 4. Then go to 4, mark 2. So this is the adjacency. Rest of all will be filled with 0. 0 means that we do not have any s between that ij. Okay, that row and column. Here row and column act as a node, so we'll fill 0 with it. So this is the way to represent a graph by a adjacency matrix. What I have done, if there is an edge between 1 and 2, then I will mark I, J, suppose this is I and J, then I will mark matrix of I and J as 1, otherwise it is 0 because 0 means that is no edge between them. Now what will I do? Go to another example so that we can have a clearance over there. So suppose I have 1 and there is something over 2. I have to change this color. Okay, I have 2 over there, then I have 3 over there. Suppose this type of have given. So what, how many number of vertex we have? N is equals to 3. So we have to draw 4 cross 4 matrix. Then we have what are them? 0, 1, 2, 3 and 0, 1, 2, 3. We have N1 4 cross 4 matrix over there. Then we will see the graph 1 and 2 are connected. So I will go to 1. Okay, mark with red. I will go to 1, then 2. I will mark 1 and 2 as 1. Then if 1 and 2 are connected, then means 2 and 1 is also connected because this is indirected graph. So I will go to 2 and 1, mark this connected. Then after that 2 and 3 is connected, so I go to 2 and 3 and mark as 1. Then 3 and 2 are also connected, so I will go to 3 and mark 2 as connected. Rest of all it is not connected, so I will fill with 0. This is the way to represent via adjacency matrix. So what is problem in this? So that we have to move our adjacency list because it is a good way to represent matrix. The problem over there is our graph is sparse. So see there we have only three nodes 1, 2 and 3, but we are taking space 0, 1, 2, 3, 0, 1, 2, 3, that we are taking space 4 into 4. And suppose this space is very much, suppose one element is 1 and other element is, suppose other element is 10 to the power 9, then we have to draw 10 to the power 10 matrix, but only these two nodes is connected. So much of space wasting, so much waste of a space there. So what to the agency list? We so for this problem we have to move to agency list. In agency list, what will have, that we have one, what we have it, a hash map over there. Okay, hash map over there. Suppose there is one node, I will fill all the nodes which is connected with one. So let me give you example over there. So let me take same example. So this is one, this is 3, 2 and 3, this is 4, this is 5 and this is 6. So this is our graph and we have to represent with using agency list. So we will take hash map. Okay, what we will take is hash map. In hash map we will represent our node as a key. So suppose one is our one key. So what will we do, that every node connected to one will insert it there. So 3 is connected over there, so I will represent 3. 2 is connected over there, so I will insert 2 here, but no other node is connected over there, so I will move to 2. Now with 2 there is 1 connected over there, and there is 5 also connected, there is 4 also connected, so I am marked with this. So now go to 3. Now 3 is connected with 1, is connected with 4, is connected with 5. Now we'll move to 4. 4 is connected with 6, 4 is connected with 2, 4 is connected with 3. Then again I will mark to 5. Then 5 is connected with 6. 5 is connected with 6, 5 is connected with 3. So 5 is connected with 3. Then after that 5 is connected with 2 also. So I'll move to 2. Then now when 6 is connected with 4, 5. So I will 4 and 5, right? So this is the way to represent via adjacency list. But most of the case we don't represent with hash map because if you notice this 1 2 3, these can be used as an index also. But if a graph don't have a regular index, like one node is 9, another is like 19, other 1900, so in that case we have to use as a map here. But most of the case all the elements nodes will be in the order from 1 to n. So we'll use um, in case of hash map is adjacency list. And what is adjacency list? Suppose we have an array list of list. So what we'll do, suppose we have a zeroth location. Zeroth location is no one is connected with 0, but at first index we have connected with 3 and 2. So what we'll have is like 3 and 2, 3 2. Then again we have okay, so now we don't have anything. So okay, no, we have. Then again we'll move to next. Then this is first index. So first index means first one node is connected with these nodes. On second index, what we have is 154. In list we have 154. It means that second node 2, like node 2 is connected with let me give you 5 4 and 1. So in this I have 154 and so on. So this is the way to represent adjacency list. Now how will take input? But we have to take input in most of the case interviewer, or we have given some graph over there. But if you want to take input, then we also see like how to take input of graph. So first of all we'll discuss the case of agency matrix over there. So in that case what we'll do, that suppose first of all I will need number of node. So I will declare nodes, I will declare vertices. Then after that what we'll do, I will iterate all the times that we need our edges. Then I will what will do that I will iterate for number of edges, that okay. Then after that I will take input from user, like what you want to, like suppose we have int u and v, these two nodes that we have to connect it. So I will take user from in I will take input from user u and v also. In any level I am writing the pseudocode, you have to take input in any language you want, that you are comfortable with. So int uv you have declared, I will take input at which two nodes you want to connect. So these two nodes I want to connect. Now I go to suppose we have a matrix, then I go to u matrix of b, then I am marked as 1, and then again also I go to matrix of b and matrix of u, I will mark as 1. As simple as that. How I will iterate through every number of edge. Suppose there is m is, we have to go to m is, that which two nodes are connected. I will take input from the user that which two nodes are connected. Then after that I will mark matrix ub1 and matrix of bue1. What will the case of in case of agency list? Let us see this also. So what will do again, I will take input of number of vertices, number of edges, I will iterate through. And again we have something called list of int, because we need a list. And suppose we have marked integer, sorry this is not think. What we'll do, I have a list of integer that have a graph, suppose graph and n cross 1 n plus 1, sorry. Then I will iterate through for loop, I will iterate through every loop of sorry, every edges. I'll go to every edge. I will take user the what two nodes you are going to connect. Suppose we are going to connect. Then after that, I will go to graph u that this node go to this index. Then I will what I will do? I will insert that b over there. Then again I will go to graph of v like this node and I will insert with at dash index I will insert u also. So these two are the way to take input from the user by agency list and agency matrix. After that, this class we are going to discuss about traversal of graph. Thank you everyone.